Hello, this is Abdalah SOBEHY. Welcome to the presentation about my PhD thesis in machine learning-based localization in 5G. I'd like to start my talk by showing you three applications and extracting the common aspect between them. AI has replaced conventional methods long time ago, since this AI-powered cat replaced Tom in capturing Jerry efficiently. Also, in autonomous driving, cars are able to drive in full autonomy. Last but not least, in Amazon warehouses, these robots transfer products from one place to another efficiently. The common aspect between these applications is the localization, which is the ability to know the position of the device and also entities around it. That's why it gained a lot of attention from the academia and industry, and there are several sensors to capture information, like lidar sensors, cameras, radar sensors, satellites for GPS. The source of information that I use for my work is coming from the 5G. Useful information such as time of arrival, received signal strength, and channel state information are used to capture localization information. Machine learning is used to create models that maps between this information and localization of devices. Finally, machine learning and 5G are strongly related, as heavy-duty machine learning processes can be done on the cloud. My most prominent contribution was done in IEEE Communication Theory Workshop competition, where in this indoor environment, a transmitter is traversing a 4x2 meter table and communicating with a MIMO antenna. As shown in the sketch here, it's a 2x8 MIMO antenna. At each antenna, there are 924 subcarriers on which the transmission occurs. The main source of information, CSI, is a representation of the channel effect on the signal, and it's a complex number. We as competitors receive a data set of 17,000 samples, and it's up to us to build the models to create the mapping to the location. The first step was to do a qualitative and quantitative analysis and deduce that the magnitude is the most stable component. After that, we use a noise and dimensionality reduction technique to reduce the 924 points in one antenna using polynomial regression and Fourier transform. After that, we use several machine learning models, such as multi-layer perceptual neural networks, convolutional neural networks, and k-nearest neighbors. Coupling that with enhancement techniques like data augmentations and ensemble techniques guaranteed us a 2.3 centimeter mean square error in the competition. This accounts for a 15-time improvement in comparison to the baseline performance by the organizers, and guaranteed us the first place among 8 teams from highly reputable institutes such as the University of Toronto from Canada and Heriot-Watt University from UK. In conclusion, localization is a very essential aspect of many applications, and it's thriving even more with 5G and machine learning. I'm proud that I was able to compile my work in 6 publications, including highly reputable conferences and journals. And finally, my work was cited 14 times from external researchers, and hope it will be a building block for further discovering in the scientific community. Thank you very much for your time.